In this video, we're going to learn how to find the exact values of the 6 trigonometric functions of a given angle. If any of the functions are not defined, we'll simply state not defined. Suppose we want to find the value of the 6 trigonometric functions of 11 pi over 4. The angle 11 pi over 4 is a multiple of pi over 4. Each of these dotted lines represents an angle which is a multiple of pi over 4 between 0 and 2 pi. If we consider each quadrant of the unit circle and look at the multiple of pi over 4 for each one, we can come up with the coordinate points for each angle. For example, in quadrant 1, the coordinate points are square root 2 over 2 over square root 2 over 2. This is quadrant 1. For quadrant 2, our blue dotted line representing another multiple of pi over 4, we have the coordinate points negative square root 2 over 2, because x is negative in quadrant 2, and positive square root 2 over 2, because our y coordinate is positive here. For quadrant 3, our next multiple of pi over 4, we have negative square root 2 over 2, negative square root 2 over 2. Because in the third quadrant, both the x and y coordinates are negative. And finally, for our last multiple of 4, in quadrant 4, we have coordinates positive square root 2 over 2 and negative square root 2 over 2. So now we need to determine the point on the unit circle that corresponds to 11 pi over 4 as an angle in radians. To determine which quadrant it's in, if you don't have most of your points on the unit circle memorized, but you do know how to convert from radians to degrees, that's one helpful technique you can use. So I have 11 pi over 4. If I multiply that by 180 over pi, I'll be able to find the angle in degrees that corresponds to 11 pi over 4. By cross-canceling, I can simplify to get 11 times 45, which equals 495. If I subtract 2 pi from it in the form of 360 degrees, I'm left with 135 degrees. It's important to note that 135 degrees is not the angle represented by 11 pi over 4. The angle in degrees that corresponds to 11 pi over 4 is 495 degrees. However, by simplifying in this way, it helps us to see what point on the unit circle 11 pi over 4 is going to fall. For example, what it's going to do, if we start at 0, is we're going to make one counterclockwise revolution around the unit circle, and then we're going to keep going, and we'll end up, it's getting a little cluttered here, but we're going to end up at this set of coordinates. So we're using the coordinate points negative square root 2 over 2, square root 2 over 2. Alright, so now we know the coordinates we need to use. It's time to find the values of the 6 trigonometric functions. Sine of 11 pi over 4 is equal to positive square root 2 over 2. That corresponds to the y-coordinate of the ordered pair that we've identified as being the correct one that corresponds with 11 pi over 4. Now we'll identify cosine of 11 pi over 4. That corresponds to our x-coordinate, so it's negative square root 2 over 2. To find tangent of 11 pi over 4, it's the coordinates y over x, so that is square root 2 over 2 divided by negative square root 2 over 2, which becomes negative 1. Cotangent of 11 pi over 4 is equivalent to coordinate y over coordinate x. Coordinate x over coordinate y. I wrote that correctly, but I said it wrong. So negative square root 2 over 2 divided by square root 2 over 2. And again, that equals negative 1. Next, we'll look at secant of 11 pi over 4. That's equivalent to 1 over the x-coordinate. So that's going to be 1 over negative square root 2 over 2. Multiplying by the reciprocal, that gives us 1 times 2, negative 2 over square root 2. We can rationalize our denominator. Multiply these together. And that gives us negative 2 square root 2 over 2. And we cancel out the common factor. And we're left with negative square root of 2. Finally, for cosecant of 11 pi over 4, that's equivalent to 1 over y, which is 1 over square root 2 over 2. Again, we multiply by the reciprocal, so we have 1 times 2 divided by square root of 2. Rationalize our denominator again, so that we don't have a radical in the denominator of the fraction. That gives us positive 2 square root 2 over 2. Cancel the common factors. We're left with positive square root of 2. So if we backtrack, we see that the value of our 6 trigonometric functions for the angle 11 pi over 4, for sine, we have square root 2 over 2. For cosine, we have negative square root 2 over 2. For tangent, we have negative 1. For cotangent, we also have negative 1. Secant, we have negative square root of 2. And cosecant, positive square root of 2. I hope you found this video helpful, and we'll see you next time.